లాగిన్ బుక్లో సైన్ చేయండి అందరూ. ఫోన్ చేయాలా
సార్ ఇక్కడ వాటర్ బాటిల్ మంచిదే కదండి.
వాటర్
రాస్తావురా ఎగ్జామ్లు మాత్రం రాయికిరా పేపర్లు ఇచ్చినట్టు చెప్తా 2 రోజులు ఇస్తాను మొత్తం పేపర్ మీకు ఒక్కొక్కడికి వాయించి సర్టిఫికెట్ బాగానే ఉందా సర్టిఫికెట్
బ్రైట్గా ఉంది. ఆ బ్యాక్గ్రౌండ్ పైది ఓకే గ్రీన్లో, కిందది వైట్ కాకుండా ఇంకేదైనా గ్రే అలాంటిది ఏదైనా.
ఇదా ఇది వైటే పెట్టండి,
వైటే ఉంటుంది
ఎందుకంటే క్లారిటీగా కనిపిస్తుంది.
అప్పుడు కింద గ్రీన్ బదులు లైట్ గ్రీన్ లాంటిది ఏదైనా పెట్టండి. బాగుంది, అట్రాక్టివ్గా ఉంది. ఎందుకు చేస్తున్నారు అది?
ఏం చేయలేదు చూడు పెట్టు.
ఇప్పుడు దానికి మీరు అమౌంట్ పే చేయాలా?
దేనికి?
ఆ సర్టిఫికేట్ జనరేట్ చేయడానికి. డైరెక్ట్ ఆన్లైన్లో ఎన్ని కావాలంటే అన్నీ వచ్చేస్తాయి విత్ నేమ్. రిజిస్టర్ ప్లేస్ ఇస్తాయి, ఇంకో 2 రిజిస్టర్ ఉన్నాయి వేసిస్తారు. నాది వేసుకోవాలి.
అది వేసారా ఈరోజు సబ్మిట్
మీరు
చేసాను.
వేసేస్తాను, మీరు వేసేస్తాను సార్.
మేడం వీళ్ళకి అరేంజ్ ప్రోగ్రామ్స్ చెప్పాను అవి చేయాలి వీళ్ళు. మేడం నమస్తే మేడం. మేడం ఓకే. అయ్యో అవునా, ఓకే. నేను ఈ సెషన్ దీంట్లో పడిపోయాను, చూసుకోలేదు. మేడం వచ్చారా మీరు ఇప్పుడు? మేడం మేడం లంచ్ అయిపోయినట్టుంది. అవునా అవునా, అయ్యో సారీ మేడం, సారీ. ఎంతమంది ఉన్నారు మీరు? పర్వాలేదా, ఏమైనా ఉందా? నేను వస్తాను, కిందకి వస్తాను ఒకసారి. ఓకే నేను వస్తాను మేడం. ఏంటి? ఓకే పెట్టారు, కానీ ఇప్పుడు ఐటీ వాళ్ళు ఒక 3 వచ్చారంట. ఒకసారి వెళ్ళండి, అక్కడ వెళ్ళారు. ఒకసారి వెళ్ళండి, అక్కడ ఉండండి కాసేపు, ఒక 2 minutes. సరే మళ్ళీ మీరు వెళ్ళండి అక్కడ లంచ్ అయిన వరకు. లంచ్ అయిన వరకు. అవును తెలుసు తెలుసు, అవును ప్రశాంతి మౌనిక వెళ్ళి. ఒక్కసారి వెళ్ళండి సార్. ఓకే ఓకే, సార్ రాగానే స్టార్ట్ చేసామని చెప్తాను. ఇంకా రాలేదు కదా సార్. సరే సరే ఓకే. మాధురి మేడం, మేడం 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 భోజనం చేస్తారా? ఓకే, సూపర్ మేడం. రైట్, రెడీగా ఉన్నారు కదా? సరే సరే, ప్రాక్టీస్ అయిపోతుంటారు మేడం. మేడం ఫుల్ ప్రాక్టీస్ ఉన్నట్టున్నారు. సరే, ఓకే మేడం. మేడం సార్ లాగిన్ అయిపోయారు, సింగంనేని క్రాంతి కుమార్ గారు. ఒకసారి సార్ని ఒకసారి అనేసి అప్పుడు స్టార్ట్ చేశానని అడిగేసి చేసాను. మేడం మేడం చెప్పండి. చేసేమనండి మరి, ఇంకెందుకు, సార్ వచ్చేసారు కదా. ఒకసారి సార్ని ఒకసారి సింగమనేని క్రాంతి కుమార్ అని ఉన్నారు. జస్ట్ సార్ క్రాంతి కుమార్ సార్ కెన్ వి అని చెప్పండి అనగానే ఆయన ఓకే అని వస్తారు. Please allow you once. At 3:30, I would like to check all your things, right? So you people complete 8 programs of various. Last class various programs and you people can complete all those programs.
Good afternoon, one and all. Present here. A very warm welcome to day 5 of FAPDP on quantum computing and machine learning, bridging quantum theory and intelligent system. Today we are privileged to have Dr. Kranti Kumar Singamneni with us. Once again, to continue this enriching journey, we look forward to exploring more advanced application under his guidance. Without taking much time, I now invite Dr. Kranti Kumar Singamneni to begin day 5 of this session. Sir, over to you. Sir, over to you.
Yeah, my screen is visible to you.
Yes, sir.
Yes, it is visible, sir.
Right. Yeah. Thank you very much, madam, for today's invitation. So, good afternoon to everybody. In previous session, as part of Ocean, we talk about very minute things, something related to in what way we can combine quantum principles. Hope my voice is audible to you, all right?
Yes, sir.
Right. Thank you, madam. Thank you. So specifically, yesterday we tried to address what is the purpose of moving from classical computing to quantum computing. And there are many combinations of many different types of disciplines are there, domains are there. So with respect to the theme of this particular faculty development program, yesterday we discussed about a small amount of content relevant to the artificial intelligence and the machine learning concepts. And we try to differentiate with the classical computing, what are the advantages and disadvantages, and when we are combining the quantum properties or superposition entanglement properties, when we try to apply those particular things on the machine learning algorithms, in what way they can differ, and what is the we try to address about what is the precise difference between classical computation and quantum computation, and what is the difference between classical bits and quantum bits, Usually we call it as a qubits. So afterwards, we talk about in what way, for example, we just way back to the starting era of classical bits, in what way we learned how to convert those decimal number system to binary number system. Now we come up with a new paradigm that is called quantum computing, and this is the time to convert the classical bits into quantum bits. So for that purpose, we discussed about what is the specific concepts or execution part needed to convert classical bits into quantum bits. That is, we talked about data encoding techniques and quantum future maps, quantum kernels. And in encoding, we demonstrated by using Qiskit platform about what is basis encoding, what is amplitude encoding, what is rotation encoding, and how can we combine these three things to project a hybrid encoding according to our requirement. Once it is converted, how can we utilize those things on the AI or ML relevant applications? How can we combine a particular state with a particular future? There we talk about that quantum future maps, Z future map, ZZ future map, and followed by instantaneous future maps, also IQMP. So we executed some sample individual snippet of the programs, and we end up that we conclude that we considered one classification algorithm, and we compared those two things and conclude that when we add some quantum principle to the one of the classification algorithm, that is support vector emission, the accuracy is better than whatever the things we executed by using support vector emission classically. That is the end of the discussion yesterday. Now, my slide is visible to you all? PPT is visible to you?
Yes, sir. Yes, sir.
Yeah. Thank you, sir. Thank you very much, sir. So today, that advanced is because in 90 minutes, so we are not able to talk about much more things. So here today, I try to combine some generative AI, because people are talking about ChatGPT, large LLM models, many things are there. So here, in this today's session, most of the time I'll spend on case studies, in what way this entanglement property, in what way that quantum superposition. For example, if we consider the 3 qubits, we can generate 8 possibilities. With each possibility, it can surrounding all the total probability of 0 to 1 for each, because classical bits can represent only one state. Because of the superposition property, each qubit can represent multi-states until we measure it. We take up 2 qubits, 3 qubits, 4 qubits on Qiskit platform, and we try to assign, for example, if we consider maybe a doctor having a big data set of the patients relevant to COVID. So, for example, when we pass that quantum, that COVID data set to a quantum Gen AI or a quantum algorithm, in what way it can calculate, in what way it can assume, it can create multiple possibilities and pre-calculated when the data is available. Because yesterday I have shown one demonstration about in what way a linear search or sequential classical search differ with the quantum search. Today we try to prove that in what way at a time, by using data set at a time, how can we take that the quantum search is possible, and how can we take the predictions, and how can we come up with the conclusions. So like that way, we will consider one anomaly fraud detection and data set, whether it is synthetic data, because I try to work with, I can download some Cargill data sets, and it is around almost 17.5 GB for that IoT data set. So I tried it, but still that is executing only, still it is not possible. So in 90 minutes, it is not possible to execute those things, and it is not possible to analyze the results for that real-time data. So that's why I come up with a synthetic data which is fit to, is possible to explain in this particular session within 90 minutes. Let's see. Before that, we talk about some basic things. What is different types of evolution of artificial intelligence. So what is the specific things, in what way it is coming, and basically this artificial intelligence is a broad field of CSE domain. performing tasks that typically requires human intelligence. We trained it. Human intelligence means I can say that, for example, if something is happening, so what is the reason to that happening? Reasoning or view or perception. Based on that, we can take effective decisions. From the decisions, we can learn whether we take the decision good or bad. If it is good, extend the same thing. If it is bad, again changing the decisions, again go with the things. So yesterday we talked about that thing also. So this is we started about artificial intelligence and what kind of machine learning and different types of deep learning models. Again, we try to combine. For example, if you consider a deep learning model, it is a part of the same machine learning, but there we use multi-layered neural networks to learn somewhat high-dimensional or complex data that can represent automatically, which is far more better than the machine learning. So basic idea of deep learning model is it act as or pretend as a human neural networks by using many hidden layers that progressively extract features. So for that one, we go with early versions of ChatGPT before GenAI come into the picture, and the version of DALL-E, a generation of images, and speech to text systems. Some combinations are there, and that is something about deep learning. And if you consider it is convolutional neural networks, it is a specialized type of a part of deep learning only. This one is something like how can I say that? This deep learning architecture designed for specifically for image and video processing using convolutional operations to automatically learn that specific spatial patterns. So there we talk about specifically learning about what are the how to identify a specific edges, or how to identify shapes or objects, or some animation scenes through hierarchical convolutional layers. So this is under this one you may consider image classification, or by using image classification we can imply the same thing for medical imaging analysis, face recognition, and some video surveillance. Many combinations are there. I don't remember all the points. So, but in case of convolutional neural networks, the main advantage is for excellent for visual data, for graphical representation, and good feature extraction and parameter sharing also. And the problem with this is it is not specifically suitable for what we call time series data or sequential data. It needs a large amount of labeled images, and sometimes it is vulnerable to adversarial attacks also. It is something about CNN. Again, the next version after that one, we go for the generative AI. So basically, GenAI means it. As of now, before GenAI, when we are trying something, automatically it learn and it just predict or classify what we are giving. But it is not having any intelligence to create its own things, its own view of it. It is not possible to generate imaginative things. But in case of GenAI, it is somewhat advanced. It is a branch of artificial intelligence only, specifically focus on creative work, creation of some new content. It is not just analyzing or classifying information as we did with the previous models. So it may include that creativeness is a combination of I can say that text or images. Images means not what image we are passing, but if you are prompt correctly, whatever the thoughts in our minds when we are prompted, it take up those instructions and it can create its own image which is not given by you. That is its own intelligence. So how it happened? Because GenAI models learn from large data sets, find hidden patterns, and then create entirely original outputs. That is the main contribution of GenAI. Original outputs that resemble the style in what way, or the structure or form, what they learn from that whatever the large data sets we are passing. So this is different from traditional AI models, which mainly prediction or classification or detection of patterns, what we are giving. So, but Gen AI goes to a step further. It can create. That's what people are using ChatGPT, for example, when we are asking about one email, one prompt, it automatically generates an image which may not be existed in the Google, may not be existed elsewhere. It creates its own things, right? So the main purpose of this particular Gen AI, the key characteristics, I can say that. So it is something possible to create something, and in what way our traditional artificial intelligence, pattern learning, learns from the massive data sets and the context awareness. That means for example, when we talk about a cell, that cell maybe belongs to a part of Excel, or cell maybe belongs to a biology, or cell may be a part of a battery, or cell maybe belongs to some other thing. But when we're explaining the context, the generative AI has the capacity to understand exactly what that particular goal, where it belongs to. And also multimodality, works across combination of textures, images, audio, and more, sometimes graphical representation also. So examples, tools we are already familiar, that is ChatGPT, DALL-E, GPT-4, Claude, Gemini, Perplexity, many things, Sora for generation of video. So many things we are already familiar with those things. And next one, so where we are using this generative, what is the purpose, and where we are using in real life for now, for according to current market. So we may use the Gen AI in case of healthcare, for example, for effective report generation or drug design, or to support the diagnostic information based on the previous models what we passed in healthcare and education sector, personalized tutoring. For example, when I'm asking about one definition, what is Gen AI? By default, it come up with one standard definition. Again, when you change the prompt that I am studying 10th grade only, or I am studying 5th class only. So based on my understandable levelity, please give the definition of Gen AI. So it again reframing everything and personalize according to your question. You try it in ChatGPT also. When you ask something, explain something, but when you're asking that, see, I'm studying 3rd grade or 4th grade. So according to my intellectual level, according to my, what can I say that, my capacity, you please give me in that way. So it can automatically, drag down with the state, taking some real-time example relevant to that particular age and frame it and give it. That is in that way you can use those Gen AI concepts in education. In case of marketing, it is for branding purpose or advertisement purpose we may use. And in case of IT and software, of course, for example, in ChatGPT, we are using for generation of codes, right? Python code, whatnot. It can use for code generation or code fixes, or for automation purpose, for testing purpose, whatnot. You can use any combination, right? And entertainment, it can create your own art, music, animation. Or if you look at that one in Karnataka, they created an entire movie, 1.5, what can I say that, 90-minute movie. That hero is animated, that hero is generated by that Gen AI only. That heroine, characters and everything. There is no realistic artists are there, but still they created a movie of 90 minutes by using the base of these Gen AI concepts only. And in case of business also, for document drafting or chatbots specifically, for example, if it is an e-commerce site, by default, it can design the previous, because as of now, we have thousands of e-commerce sites. We pass all these e-commerce sites to that model, then Gen AI understand everything. And when you prompt that, my e-commerce site is something like a food delivery system. So it can create a chatbot relevant to that particular food delivery system questions only, queries only. For example, it is something like it is something like Amazon or something like Flipkart e-commerce site. So based on that one, it can create that is personalized interactions, and based on that we can go for the decision support. So and simple thing, I can say that at the end of the thing. So generative AI that represents a significant advancement in AI capabilities, enabling machines to perform own creativity and produce content that was once thought to be uniquely human. In what way, when I ask you something to other person, he's sharing his experience. He's sharing in the same way, it responds back. So that is something about generative AI. So again, it contains many things. As from generative AI, we go with different types of models are there. Sometimes we call it as a generative adversarial networks or variation autoencoders or some transform models. I don't remember more things. Some content. So this is the way we can use the generative. So it is the evolution of everything from artificial intelligence to machine learning to deep learning, and deep learning to convolutional neural networks, and convolutional neural networks with Gen AI, and Gen AI to some other things. So here we talk about some explainable AI. So here we provided a detailed comparison with the different types of models and different types of things. So with respect to explainable AI, I can say that it provides a design to provide transparent and interpretable explanations for their decisions. For example, when we are asking something to take a decision, we can ask that in what basis you prefer that particular option. So it need to explain these are the bases based on these decisions, based on these differences, based on this content, we come up with this idea. So that means it makes AI understandable to humans, enabling trust and accountability. For example, it may be used for explaining medical predictions, or maybe explaining some for example, when we are applying for any house loan, at the time your particular agent is asking about multiple documents manually, you are signing everything. But if once this explainable AI come into the picture based on the government policies, it can extract government policies are relevant to state government policies, relevant to central government policies, relevant to what is the interest rate at that particular time. It can consider the real-time information, and based on that one, it can come up with, based on the CIBIL score, also real-time CIBIL score. Then it can come up with one particular output that whether it is possible to sanction the loan or not, whether this property is applicable or not. In some states, that particular policy may be worked out. In some other states, it may not work. So by using personalization, we can differ those things also, right? And the specific disadvantages, it is we need to difficult to apply to deep learning models with all multi-levels or lowest levels, and because of this interpretability and additional effort we need to spend on for explaining things may reduce the performance, and that is something about that one. And if you look into responsible AI, this specific purpose is when the AI artificial, we train something, we design something and deploy. For example, in ChatGPT, we may ask about when you send one particular Aadhaar card details, I need the person details. It doesn't need. The responsibility means up to what extent, what is your access policy? What are the things need to be asked? What are the things need not to be asked? Even though when we're asking, when we're using keywords called password or security, so it may give the generalized information. And when you want to download some textbook, you try it in ChatGPT, it never gives, because when a particular paper is published article is belong to some Springer or some other thing, it comes up with a prompt that it is out of it. It is restricted that it is not possible to provide those things because of these guidelines. So here, responsible AI means it should be fair, transparent, and accountable, and something related to privacy preserving. It should not leak or it should not give the other person's data to you. That is the main intention of responsible AI. So we can use this AI fairness in recruitment process or bias-free loan approval process, privacy preserving AI in healthcare. We may use many applications are there. Those are some of the possibilities. So now, if we just move to, as of now, we talk about a standalone classical artificial intelligence evolution. Now, in this, now I try to combine. If we combine the quantum principles or quantum computing with this artificial intelligence, if you combine this one, so what are the possible things are here? So here, this picture shows that in what way, if you're combining artificial intelligence with the quantum, these are the possible different applications are there, or different classifications are there. One is shallow intelligence, and deep intelligence, and abstract intelligence. Shallow intelligence, it is something like, it refers to a quantum enhanced version of traditional ML models only that rely on statistical referencing and pattern recognition and low complexity models. So they typically involve quantum speedups in algorithms like, as we explained in yesterday's, something like classifications or regression or clustering and dimensional reduction. Here, when I talk about this particular statistical interference, the intention is here, it used quantum computing to accelerate that particular, enhance the classical support vector measurement models to, with the adding of this quantum data encoding techniques or quantum, yesterday we discussed about that quantum kernels and quantum future maps. By using those properties on that one, and it can show the better performance. In case of pattern recognitions, it is integrating quantum with the amplitude encoding, for example. In that case, it can allow faster extraction of the patterns in large data sets. That is the beauty of amplitude encoding. It is a part of quantum only. So the main advantage is it is very good at training very fast. Faster training compared to classical machine algorithms, and handle complex and high-dimensional data, as you know that efficiently, and the enhances or improves clustering. Because why I said that improvement means, yesterday, for example, in case of amplitude encoding, the main part is when we are passing 100 bits, for example, when we are passing 16-bit, we need only 4 qubits here. So processing of 16-bit, the time required for processing of 16 classical bits, the time required to processing of 4 qubits, when we are comparing, these 4 qubits performs well. In that way, we can support our statement that faster training or faster decision, or improve the clustering, or improve classifications, or improve some other thing. So the main disadvantage is this particular thing not very suitable for high complex tasks because of long sequences and reasoning, and sensitive to quantum noise. Still, we don't have, still hardware is available, but because of this quantum noise, many data is misleaded, and because of that, more errors, the predicted or occurred or obtained output may not be service the purpose. And in case of second one, deep intelligence. So here, the main purpose of deep intelligence is it refers to a quantum enhanced deep learning architectures, which is capable to self-organization and representation of particular learning or symbolic reasoning. It includes hybrid quantum classical neural networks also. So in this way, many combinations are there. So here we talk about those 3 things. And next, these are some of the applications by using quantum artificial intelligence. Yesterday we had some time to discuss about that Grover's and Schwartz algorithm. So searching process is very fast in Grover's. That means it can accelerate specifically on searching of unstructured databases, unstructured search problems. offering a quadratic speeder, which is somewhat better than the classical search. For example, usually on an average in classical search, we may take order of n times time complexity. But here, within order of root n times also, we can get searching results. The basic idea is same. Here, they use the amplitude amplification or data encoding technique to identify best or optimal or required states from large data sets. Because among those multiple data sets, which are favorable data sets, it can filter those things and discard the other all things. So these Grover search we are using in many ways, identifying the optimal chemical compounds are in unstructured. We discuss unstructured and something like fraud detection or anomaly detection. I don't remember exactly those things. So it is something about the intention is searching process. Grover's is a quantum-based algorithm. Searching is very fast there. And in case of if you consider quantum linear solvers, so this one linear solvers, this one it solves large systems of linear equations exponentially faster under certain conditions. We need to provide that hardware conditions and what things. There are some limitations are there. That is designed. These things are designed for something like power distribution or design of energy. So on yesterday, we already discussed about this data encoding technique also. So for those things, we may use for fault diagnosis of energy systems. In the coming slides, we come up with the different types of case studies with hands-on. We try to take up some healthcare synthetic data, some fraud synthetic data. Based on that, we can perform some of the applications. Now, so anyways, we talk about all these generative ways and everything, right? Gen models, that is complete variation encoders. Right. Okay, fine. And these are some of the applications of GenAI and the quantum and regular industries and healthcare, finance, cybersecurity. So in today's session, we will try to execute some codes related to healthcare and some finance and cybersecurity also. And this timeline in Broadway from 2024 recent days. So it shows how generative AI evolved over the last decade. So it started in 2014 when that GANs, that is adversarial networks, were introduced, which marked the beginning of machines being able to creating some realistic images. So in case of variational autoencoders, are more stable and structured ways to generate new data. The big leap came in 2020. So this is the evolution of in 2022 based on these GPT models. We come up with ChatGPT, and still things are going on with the latest models. And on top of the GenAI, we are adding some explainable AI concepts and responsible AI also. And based on this research company, a business research company of the market report, it shows this particular chart shows how fast the global GenAI markets is growing. If you look into 2024, it is almost that valued around 23.8 billion, and it is expected to jump over 34 billion by 2025. We are showing all the approximate results. By 2029, it is around 113 billion. So it is not just a technology trend. It is becoming, how can I say that? It is becoming a major economic force which shapes the future of the industry worldwide. That is something like. And this is something related to global generative AI market. So here we extend the same thing for market.us, which is available. So it simply shows that how the global GenAI market is expected to grow from 2020 to 2032. So by 2025, by this year, the market is projected to reach nearly almost 24.8 billions. So the graph shows that GenAI is becoming one of the fastest growing technologies. As we see, if you look into the entire millions of people, every day they are using ChatGPT. In olden days, when you want to frame something, a mail, or if you want to write an official mail to your subordinate, at least from myself, from before ChatGPT, I need to spend almost at least 30 to 40 minutes of time to frame one mail and checking for grammar and everything. But now it's a matter of 2 seconds, 3 seconds. For example, you want to apply for you. Just give a prompt that a mail to a manager with the so and so causes. It will give excellent mails also. So people are happy with that one, and multiple people are using things. This is the way we can show that one. And this is the from the president research we extracted this GenAI market. The same thing here also is showing that by 2034, almost $1,000 billion, the growing of GenAI usage. Now come to the hands-on session. In what way extended we explain about what can I say that data encoding techniques and kernels. Here the main point is we want to build a quantum generator, a circuit. That circuit may be a combination of multiple quantum gates, fundamental gates, X, Y, Z, and based on the necessity, we can apply rotation X, Rx, Ry, Rz. On top of that, we can use some data encoding techniques. Now, what we are using here. So for now, here we are using use a two qubit quantum circuit, parameters with the Ry gates, measure the output state probabilities. So yesterday we talked about the theta and phi signs, which influence the phase estimation and amplitude information. So back to our the purpose, I'll explain that once we execute that Qiskit platform. So what we are using here, quantum circuit, we generate 2 qubits, right? Okay. So first, associating both for performing those things we use these two. We run a classical simulator A here. It is also from the simulator. So for encoding purpose, we need to pass the classical data or as vectors. Those fields are available in NumPy as NP. And for generation of results in graphical representation or visuals, we use Matplotlib. I go with PyPlot. Right. Now, in the second phase, as I explained here, I want to define a 2 qubit quantum circuit. 2 qubit quantum circuit. For that purpose, I define a variable QC, which is that we are extracting from a class quantum circuit of, I need 2 bits, right? For this one, I need to apply parameters with the Ry gate, for rotation gate I am applying. So for this one, Ry theta. Initially, we start from the top of the block square, that is called from 0. that means initially for qubit 0, I'm applying Ry, and you repeat the same thing for 2 qubits, right? This the relationship with qubit. That means those two statements means we apply that Y gate, rotation Y gate for qubit 0 and qubit 1. Now I want to measure it. Can go with some 0 I1, any values, it is your wish. Here I am passing all the values, parameters, hardcoded values only. So I want to measure both qubits. Okay. Because we are not defining function, right? Sorry. You want to define, for example, I want to define some quantum generation for the same base data. Okay, here this one. Yeah, we define something. Next, what is the third point? Measure the output state, okay, we probability and analyze how changing quantum rotation and the influence general distribution. Okay. Now we need to simulate this particular circuit, and we need to get those results. That means because we pass this quantum circuit this particular value QC, so I need to define. I want to simulate on that particular QC. Simulate on what value? QC value. So for now, I need to use simulator for entanglement or for generation of multiple qubits. Here is a simulator. So, for example, I need to use transpile for this UCC, and that result is equal to same unit of run. Run is a predefined function here. I repeat the same thing for 1024 or 1080 bits, 1000 shots. Result of this one. Now I want to return this measurement. Return. And let us syntax. Run. Syntax here. Compared. It's calling right. That's right. So get counts. Now, from here, we need to sweep theta and collecting probabilities for all the states. That means my different angles are, I go with but this one we have a function called the line space. Of different angles, I go with different space means entire space covering from 0 to 360 degrees, right? From 0 to Python supports pi value from the NP only, pi of 50 possibilities. Now states For 2 qubits, how many states are possible? 0, 0, 0, 1, 1, 0, 1, 1. Sorry. 1, 1. These are the possible states. Now, probability is equal to, it is any state for above states, for stating the total states and 4 possibilities states. Okay. Now I repeat the same thing. The theta value from that the set of angles you see. For the theta value. On my count, we certainly count 1,000 values here, 1,000. We need to simulate for all the things which are available in QC. Now, for state and states, probability is equal to total counts should get this one. Of 1,000 possibilities. So, beta angles. Okay, so one for this one also is okay. What is that? Attribute attributes. What is that? Data. That is. Integrated QC equal to 1. Comes we calculated simulate QC value and for stating states probability counts state of 0 better properties. In that case, here to get values, it's that counts. So metadata. Simple thing. There are some spelling mistake is there. So now, as of now, what I did? We calculated individual values and append the probability values. Now, we need to generate some the size 12 in length. That's it. How many states we consider? 4 states, right? 4 states. I need to plot with all my angles. Use of initial state. Value of now X label. Theta. That is rotation and variance. Normalized probability of each state. Using data. Mr. said that is something one. So simple thing here. This graph represents that if you look at that one, we have a 4 different changes. That means the main intention of this particular graph is we used to draw a quantum generator by using a 2-qubit quantum circuit by rotation gates. So in next coming problem, we try to address in what way these multiple data sets or multiple state are used for these financial data or early cybersecurity simulations or in healthcare domains or everything. Now look into the sample case. Here I need to go with the 3-qubit quantum circuit to simulate 8 possible patient symptom combinations. So here in previous execution or here only we are showing 4 different possibilities, but we are not assigning any feature or any symptoms. But here what I'm trying is, for example, if it is cat 0 for one possibility, there are no symptoms. That graph should be with high probability of 1 with no symptoms. And if it is 001, some slightly favor only for one state, one representation. So by this way, for different combinations, these 3 zeros are no symptoms for one patient. Sometimes these values are automatically changing depending upon the symptoms what you're passing. So in that case, for example, we may consider for the same thing for the next extension. 3-qubit possibilities is 4-qubit possibilities are, many possibilities are there. So for example, if I extend the same thing for here also, in case of COVID-19 symptoms, assumption here I pass the hard-coded values with the 4 qubits here I'm providing. So here, by using 4 qubits, there is a possibility of 16 combinations, right? So now we try to map by using 4 qubits, 16 possibilities are there. So those 16 possibility, each possibility resembles one particular meaning. So like that way, we need to represent the values. Now we try to explore this particular thing. Right. So same thing, I just copy the things here. Right. Now we go with we define one new function called symptom. Right. Data value. This one, my measurements are. This time I need 4 qubits, right? Times a qubit of my 4 qubits. For this one, I need to apply the same RY gate because block space contains 0 to 2 pi. Among those 0 to 2 pi, I select different positions. First, I start with 0. You see dot RY. Same rotation RY rotation gate by using this time theta by 2. At the time, we need to pass theta value at the first phase. Next, you see dot RY. 3. I do one thing. I will do this one too. So this is theta by 3 and theta by 4. This is the fourth one. Fourth resemblance with 3. And next, QC. Now I apply that C0 gate for first combination 0 and 1. 0. Next, QC for CZ for 1 and 2 combination. And next, QC for CX 2 and 3 combination. Now, QC dot measure of these all possibilities. And the full combination of these 3. Right. So this is for a 4 qubit quantum generator for COVID symptom simulation. Here we pass all the values and we calculate the code. Now, by using AER simulator in same pattern, in what way? Here I'm using the quantum generation function. Here in this place I use this quantum COVID things here, simulate by using AER simulator and transpile. Same pattern here. This time I want to simulate on this particular thing. So I go with simulator on the same QC, what I read here. Now that value equal to, here I am passing the AER simulator, I perform the operation. Dot sim dot run. Here I am using the transpile QC value and the processing value. With the number of slots, it is your wish. I go for the results. Okay. Yeah, counts. So as of now, I'm taking one on keys here. Here I need to pass those layer value. Now here, next one, I need to consider number of angles equal to, for angles we use previous line space, right? Line space for 0, 0 to entire 2 pi, 2 360 degrees, 2 pi of each 50 rounds. This same states equal to that I range of. Here I'm passing 14 values, right? 2 power 4, 16 combinations. 16 combinations. Among those 16 combinations, my labels are. So labels, I already use some labels here. What are the labels we will consider here? Yeah, here are the labels. These are the total levels. So now, here I need for each theta in the total angles. Those counts should be using the simulator. Simulate. Code. Right. Not defined. So is not defined. Where it is not defined. Let's do it. Okay. Right. So now, next one, you want to generate that one by using this plot value. So that's 14, I think. It's some mistake. The lens. That's mistakes. Okay. Okay, fine. Maybe I'm getting some error. And anyways, we already collect all these things we executed previously. So if you consider this one, for explanation purpose, I write line by line. If I execute this one, if you look at this one, here the thing is, we tried different possibilities, and by using these 4 qubit states, 4 different states, among these 4 qubits, we generate different types of variations, different types of angles by using rotation Y with the combination of magnitude and angles, and we try to assign for each state with one particular symptom here. So in real time, those values may be not hard-coded. Dynamically, we can give it, but for here, I use synthetic data only. On top of that, the 4 qubits. If you look at this one, you can understand these probabilities. It gives 16 different possibilities. So first is, if you look at this blue symbol, it is the highest probability. He is not infected. That particular patient is not infected with the probability of 0. And if it is breathless only, one possibility is there with the loss of smell only, or a combination of smell and breathless. So these combinations here, I use this point. By using these CX, case, I can combine the symptoms 0 and 1, or 1 and 2, or 2 and 3, or different combinations also. By using this one, these are the different variants. And if you look into the last flat line, all 4 symptoms severe, it is 4 ones. So like this way, as we explained, by using these combination of quantum and artificial intelligence, we can use these quantum principles to show that which things are implementing, which things are not implementing. So this is the baseline. We can implement this baseline for any combinations, and in case of classical artificial intelligence and machine algorithms, at a time it can calculate only one possible value when you pass the data set. But by using quantum probability, if you look into this one, it is existing in all the states. And in among all the states, it can predict with, which assigned future state is replicated or relevance. It's showing the probability if it is existing or not, if it is not existing or not, and what are the different combinations. It can give all the possibilities. In the same way, next time we use the same concept for agriculture data set also in the same way, because when we are passing multiple data sets, based on those inside values, we can define. For example, if it is a dry, we can assign something, light rain or heavy rain, storm, sunny. We can use these things. For this one, I use this 3-qubit state, this particular thing. So here, the point is, if you look into the same concept here, I applied. Here, weather pattern, I go with the 3x3 qubits with the 3 different combinations, and we implement AR simulator and transpile for generating. Here, the labels are this one. If it is qubit state cat0, all zeros, it is dry, and cat1, 001, light rain or heavy rain, these different combinations are there. So if you execute this synthetic parser data thing, it is also showing the same form in what we are showing. So purpose is different. The base level, the quantum principles are common. See here, if it is dry, it come up with this particular highest probability. So start from 1 and from 0 to here, and it's showing in block sphere. It's showing based on that angle, it can decide which is the symptom, which is the possibility, and everything. So in the same way, next case study, we go with this one. So we can, here the point is, in case of this example, I consider these states. For example, when multiple employees are working for one company, so something based on the log record, it pre-calculated, and if it is a normal login or high bandwidth or restricted port access, odd hours access, IP switching, malware detected, DDoS symptoms, composite threat. Not only these things, many combinations are there. Social engineering attacks, ransomware, zero-day attacks, many things are there. So point is, based on those multiple level of considerations, we assign the same thing for multiple possibilities of quantum states here. So if you look into this one, it is also producing multiple combinations with the same pattern recognition. Here you can show what are the different possibilities are there. Whether it is a normal login, this is, we can automate the same process when employees are logging and log out for 24/7. Automatically, these quantum algorithms continuously monitoring all those multiple systems, and automatically when the threshold value crosses, automatically it shows that report to concerned admin officer, concerned chief security officer, so that he will take effective decisions to avoid the much loss. In the same way, the other case study. So, for example, if you look at a financial transaction, where is that financial transaction? So, where is that? This one, for example, you consider 8 behavior state. That means here I consider 3 qubits. So here the thing is, when a particular user or device are using a particular network, so using that particular network, if you perform any transaction, so after while transaction or before transaction, we train something that if it is a normal transactions or a high amount, same location or not, or small amount, whether they are using any new device or large amount new device or multiple rapid transactions within a span of time, or it is a overseas transaction. Like this way, we can collect multiple possibilities. We can add it to the existing simulation environment so that it can see the different types of probabilities based on those theta value or based on that RX, RY gate values. It's showing which one is possibilities there, which one is normal, which one is considered as a threat. So here we try to provide different types of case studies. First one is healthcare. We talk about COVID data set here, but for this FDP purpose, I use only the base code only, a toy data set, a toy code in real time to combine those things on a real time simulator. Previously, I have access to Qiskit to perform all these operations. But now it is a pro version that we don't have any much access to that one. Otherwise, I can take up the same code there itself only in Qiskit. Here, as of now, we demonstrate everything by using our local simulator platform, but in real time, you directly go to the Qiskit platform. So here, it is inactive. Right. Okay. This one. So here we can use the same thing. Workloads I can see. Okay, it's not enough. Workloads. Maybe I can see instances also. Okay, whether we have access for that or not. See here, these are the compute resources. Here, if you look at this IBM Pittsburgh, they are using 156 qubits. IBM Torino, they're using 133. All these are quantum processing units. On the real-time hardware, they are performing all these operations. If you look at this one, for IBM Pittsburgh, for this cloud, they are sending almost 1907 jobs. Still they are in pending. So what is the noise error, laid error, or total things? Previously, we have access to these things. We can maybe see here. Yeah, all these are, yes, right. Last time I used this Brisbane, I used this one, Brisbane. But these are retired cloud QPAs. But if it is available, we can write our own code on this Composer platform. We can send it to the system QPU. They processing on their own platform. They can send it back. But the main typical difference between what we are executing in our local machine by using the Jupyter Notebook, it is simulated environment. The results are very fruitful. Yesterday we discussed about that what we called quantum support vector machine. It's showing that 95% accuracy. But if you send the same code to the QPU, or to the cloud, we do not imagine that much because of that noise problems, because of that quantum transmit is very sensitive for now. So last time when we tried, it is about only 40 to 42% accuracy only on the real-time machines. So still people are working on those hardware things to get advanced hardware so that algorithms are good, but for that to match that computational speed, the relevant hardware should be very robust and noise resistant to perform those tasks. And next one. Right. So these are some of the case studies we try to address. And in last class we talked about this quantum neural networks and everything. Here I provided all these step-by-step procedure. We can implement quantum neural networks also. Here, if you look at this one, they imported ZZ future map. We already know yesterday we discussed about this one. And there is a predefined k-arrival classifier also. So if you really want to do something quantum, and it is recommended to understand the entire concept and algorithm. But even though some of these beginners, you do not need to learn much about those things, even though if you are not familiar with what is happening inside that one. Here, Python support predefined libraries. Based on that one, we can execute according to your requirements. So here, I provided entire step-by-step guide how to work with the quantum neural networks, how to train k-nearest neighbor and these things. So here, the main point is it replaces the traditional Euclidean distance with the quantum security, making it more powerful. And you know, the encoding classical data by using ZZ future map, which help create entangled states. And in case of instantaneous feature map, there is a possibility of superposition also. So this is something about today's session about multiple case studies and some clinical aspects related to GenAI. And so here in for variational quantum classifier, it is also a very important topic in this one, variational quantum classifier. It represents a prominent and accessible, most of the research work is happening on that you see a variational quantum classifier. That is something like a quantum machine learning coming for a supervised learning task, offering a layered or structured approach that closely resembles something like convolutional neural networks only. So, because here we come up with a hybrid machines, because there is no pure quantum system is available, and that's why they combine these hybrid classical quantum algorithms with the available hardware of classical. And whatever they already designed on quantum, they combine with each other for efficiently classify classical data by using the power of quantum circuits in relevant with the classical optimizers. So here the fundamental mechanism involves same encoding classification information into once it is encoding is completed, converting into that different quantum states as I demonstrated today. Performing quantum processing through a parameterized quantum circuit, often referred as once we simulate the circuit, we can measure the quantum state to generate as usual in what way we predict the classical prediction, we do the same thing here. So this particular paradigm is certainly or particularly promising for efficiently utilizing noisy intermediate scale quantum (NISQ) devices, as it allows for the implementation of classifiers for multi-dimensional data sets using only polynomial number of or reasonable number of qubits, specifically for what is called for when number of classical bits are increased automatically by using encoding techniques, we can reduce it into a quantum states with the limited qubits. We can do the same performance as we classical computer today. To that encoding technique, what we call the change of probabilities, amplitude encoding. So the process of amplitude encoding is somewhat critical for obtaining a functioning pipeline in a QML model, because it enhances the performance of data model by adding some future vectors in the quantum state, as we explained yesterday. So these are some theoretical sessions we talked about. And if possible, if you are using any laptops now, still we have some 30 minutes of time. Please install this Anaconda distribution and PowerShell, this one. Anaconda PowerShell prompt. And I will share some sample codes to you. Try to explore those codes and execute it, and I try to analyze what are the individual contributions and in what way quantum gates or quantum circuits are combined with artificial intelligence and machine learning algorithms for the better improvement of the performance with respect to optimization or efficiency or effective utilization of computations with. That is also depend upon whatever the data we are passing, whether it may be normal data or whether it may be complex data. Different possibilities are there. So once we install that Qiskit, so we implement it. It is our wish. Some people are very for specifically for quantum machine learning. Penguin is very good. That is one of the open source tool for quantum machine learning. This one. Right. So we can install this also here. Then, if Anaconda distribution is available, then open that PowerShell and just install Penguin. And that only thing is syntax differences. So, as of now, I somewhat habituated with the Qiskit platform. I use this QC, X gate, Y gate, Z gate, rotation gate. But it is your wish by exploring both the tools or platforms, which one is comfortable to you, we can go with the same thing. Here we call it as a shots, there we call it as a wires, different combination of shots. So now this is something about today we mainly talk about how can we distribute these 2 qubit, 3 qubit, 4 qubit, and maximum we can support 8 qubits also, almost 2 or 8 combinations if system supports. So based on these things, we can those who are part of those who are trying to do some research work related to this machine learning with the quantum or quantum not only related to machine learning, it is many variants are there. Quantum chemistry or quantum physics and quantum cryptography. Many combinations are there. So there we talk about one so we start working on this one from past 2 years. This is my one sample survey paper about quantum. These are the different things we can look into in this article. We try to work on all these quantum algorithms and different types of simulation algorithms, cryptography, optimization, machine learning, error correction, linear systems. Still counting, many combinations are coming. So if anybody of you are interested, relevant to this particular thing, we are happy to collaborate with you. And on behalf of Symbiosis International University, we have a set of 500 Q1, Q2 journals. There we can support the full funding also. And you can assign some modules to me, or if you have, and I have some problem statements. If you are willing to work with us, I can give you problem statements also. We can work together, and for those things, we provide a complete article processing support also from our side with meaningful interactions. Thank you very much from my side. If any discussions or things, please bring it on.
Sir, good afternoon.
Sir, Ramesh sir, how are you, sir?
Fine, sir.
Yes, sir, please, sir.
Sir, the modern cryptography algorithms,
Sir.
generally most of the algorithms are using 128-bit as the key size, sir.
Yes, sir, yes, sir.
Now the key size is also sufficient for the classical computers.
Yes, sir, yes, sir. Right,
By
right.
using any classical computer to crack that key, it requires hundreds of years.
Exactly, sir.
But when it comes to quantum cryptography or quantum computing,
Sir,
what will be the minimum size of keys, sir?
minimum size, there is no specific thing, sir, because every time when we're using a particular quantum, what we call, if you want to generate, yesterday I demonstrated one video.
Yes.
Every time when we are passing 1024 or 240 or 550, based on the what type of polarizers we are using, what type of state vectors we are using to filter those data. So after
Okay.
filtering, that size may be 4 bits also. So that size may be 128 or the size may be 16 bits also. But
Okay.
those things not even known by the third party person, theoretically. And
Okay.
up to some extent level, China and some other people are performing those quantum distribution things.
So even
They
hybrid
succeed
quantum GANs
up
are used.
to, for example, I forgot about that channel name. They perform by using quantum entanglement with the 143 kilometer distances. They generate the key. They successfully transmitted the data.
Okay.
Even the distance is more. That size cannot be exactly predicted because of these quantum states and entanglement. They may filter with a large number or a minimum number. But basic thing is, for example, in RSA, if you're using 2048 bits
Yes, sir.
per key generation, how much amount security providing 2048 classical bits? In the same way, if you're using only 120 bits or 64 bit in the qubits, they are also providing the same security, but with the minimum computational time. Minimum computation. I can say that is the generation of key is very fast.
Yes, sir. Yes, sir.
Yes, sir. So,
మేడం ఏం మేడం అంటే అయిపోయినట్టే మీరు ఒకసారి వైండ్
Sir,
అడిగి అప్పుడు చేయండి.
hello.
hello.
Sir, sir. Sir, what are the approximate cost when we are opting for any real-time quantum computers? Do you have any idea, sir? Like IBM or just Google, how much they are charging for 10 minutes or 15 minutes?
With respect to IBM, I know something, sir.
Sir.
Sometimes under for example, if you are work on older Qiskit runtime, almost per second it is around. Last time when I see that one, it is $1.5, sir.
Okay, per second.
Per second. So, but recently when I look into, they said that they want to move everything into quantum cloud. When I move that one in 2025, per minute around approximately $100.
Oh.
It may not be within our budget.
Yes, sir. Yes, sir.
So once quantum real hardware is available, sir, there it is meaningful to discuss about all these things.
Yes, sir.
Now, multiple members are asking about something. We may not give exact justification whether it is right or wrong, because still we are working on simulator platforms only. And it is not good there to decide and come with the conclusions based on that only quantum computing is excellent and everything. But there is a hope with all possibilities, even if you are not able to address multiple things, but some of the things, as of now, it addressed successfully. So I request all the participants, if time permits, please use Quiskit. Please install the package Quiskit into your respective laptops and perform some basic coding. And while any doubts, I can happy to address those coding doubts in what I explained, specifically about the data encoding techniques and about future vectors and kernels. Because almost 120 to 130 our ACT UGC giving the approval for minor degree also for quantum. So in this participant list, if anybody is there, any institute got a minor degree eligibility from the AACT?
No, sir, but we are trying, sir.
Yeah, sir.
Because ours is autonomous in our course curriculum also, we are from this academic year onwards, we are introducing both minors and majors, sir. In quantum.
Yes, sir.
So currently we are offering AIML is one honors, and cyber security is another honors, and data science is third honors. Now we are introducing this fourth one is quantum computing.
So how many credits we are planning, sir, for that one?
For each honors, 20 credits, sir.
20 credits, good, sir.
Yes,
Good, sir.
The students needs to complete three subjects, sir, 3 courses, and another 2 MOOC courses, sir. Total 5 courses.
5
to get the 20
credits. 4 credits. It's a good initiative, sir. In Symbiosis, we have some dual degree program also here. That means honors in data science and honors in cyber security. And in CSC, we are supporting with the Daikin University.
Okay.
Thank you, sir.
2 years here and 2 years there. Okay, sir, if any no doubts are there, because by 4:45 I have some other meetings, so that's why I closed early today. Sorry for that. I should have come up with some more content.
So thank you, sir. Thank you very much for your valuable time. And
Yes, sir.
yesterday and today the sessions were awesome. Really, we learned something. And
Yes.
definitely, we will be in touch with you, sir, for future announcement. And
Definitely, sir, definitely.
in April, we are planning one more quantum-related workshop in offline mode. So
Okay.
definitely, I will approach you, and your services will be again utilized for that workshop also, sir.
Sure, sir. I'll do my best, sir.
Thank you, sir. Thank you very much.
Yes, thank you all. Thank you all the participants.
Thank you, sir.
Divya, madam, please proceed, madam.
On behalf of the organizing committee, I extend our heartfelt thanks to our esteemed resource person and to all participants for making this online FDP session truly meaningful. Our presence and engagement added immense value. We look forward to your continued participation to your upcoming section. Thank you and a great day ahead, sir. Thank you, sir. Thank you for the session. All the participants, can you leave now? Thank you.
మేడం సరిపోయింది మేడం. అతను ఫోన్ కట్ చేయలేదు, ఉన్నారు. ఓకే మేడం. థ్యాంక్ యూ వెరీ మచ్ మేడం. లేరు ఉన్నారు. ఓకే మేడం.